So general layout of impulse testing method is completed, and then resistance potential divider, capacitance potential divider. Okay, so try to consider here just 1 to 2 minutes. So generator, test object, divider, meter. This is the general layout of impulse testing method. Generator generate the very high impulse voltages. Okay, and test object, that may be insulator, circuit breakers, relays, whatever it may be. Which one? Which I mean, for example, you want to test the circuit breaker, you have to place here, and to maintain, we have to maintain the proper distance. This is one location, and this is also one location, and the divider is also one location. Because of if if test object is failures, that is very dangerous to the beside equipment. Okay, if the test object is failure because of very high impulse voltage, no? Because of that, there may be a disturbance in divider and meters. So that's why proper distance we have to maintain between generator and test object, this measuring equipment. Okay, and also these are connected with connecting leads is having very high resistance, and also here the delay cable, delay cable used to absorb the external stray magnetic fields to avoid the errors. Okay, they are the simple measurement setup of impulse testing method. This is completed yesterday. So resistance potential divider. So the resistance potential divider, here there is a simple circuit. So only R1, R2, R3. Okay, so and a CRO and the delay cable. That's why this equipment is setup is very less cost. The cost of the resistance potential divider is very less because of only simple elements. Okay, simple elements we are using. So that's why the cost of the equipment is less, and also is portable. Okay, so to it is portable means it is relocate one place to another place is very easy. Okay, so because of only resistors, no? There is no sensitive parts here. That's why it is very comfortable to transfer locate one place to another place. Okay, so in this R1 is R1 here. The R1 resistance is very high. The resistance of the R1 is very high, and the resistance of R2 is less. Okay, that means here, that means resistance potential divider, no? Resistance potential divider, we are dividing the by maintaining the R1 is very high, and by maintaining the R2 is very less. So then only the voltage across the CRO is less. Okay, measuring equipment, the voltage across the measuring equipment less. So it is possible to measure by using CRO. So by converting high voltage to low voltages. Okay, the CRO is connected to the delay cable through Z. This is called delay cable. Impedance of the delay cable is called Z, and also with matching resistance R3. Okay, here R3. So the R3 is called matching resistance. The what is the purpose of matching resistance R3 is nothing but to observe the transients. Understood? To observe the transients. Clear? Mean to so impulse, na? This impulse voltage in a fraction of seconds, in microseconds, high voltage appear across the test object. So in that condition, there may be a transient. There may be a transient in waveform. Okay, there is a disturbance in the waveform. So that can be avoided by using matching resistance. Okay, so I think you are already completed in power system concept, one of the power system concept. The CRO is very high impedance, very internal resistance of the CRO is very high. Okay, CRO internal impedance is very high. That means it acting as open circuit. Okay, so CRO is a voltage measuring instrument, not current. Understood? So internal impedance of the CRO is very high. So that's why it acting as open circuit. Okay, so under the opening condition, the voltage is different. The voltage is different across the CRO is different. I mean, there may be some disturbance in between these two that can be avoided by using matching resistance in between this test object R2, okay, and in between CRO. So we have to use one matching resistance along with the delay cable. So, okay, the cable is observed the surges, well, okay, and the matching resistance is observed the transients, and also the reflections of voltage waves and the refractions of voltage can be observed by using matching resistance by proper way of arrangement of R3. The reflections and the refractions of waves can be observed by using matching resistance. Understood? So here R1 R2 matching resistance and wave shaping. So these R1 R2 are not disturbing the wave shaping circuit. Actually, this is a wave shape now. So our required wave shape is like this. Okay. Wave shaping circuit. These R1 R2 are do not disturb the wave shaping. Okay. So like that we have to adjust the in a proper way R1 R2. Okay. See, here R1 R2 do not modify the wave shape. So this is the important point. R1 R2 do not modify the wave shape. Okay, matching has to be done with respect to the impulse generator circuit. So before of that, one max circuit we are using. Before of this circuit, okay, one max circuit we are using, that is called impulse voltage generator circuit. So the impulse voltage generator circuit waveforms cannot be disturbed by the R1 and R2. Okay, there has to be internal matching with this potential divider circuit in order to take of reflections and refractions of uh, transmitting waves between the R2 and CRO. So these matching resistance take care of reflections and refractions of voltage waves. It's clear. So that is called matching resistance. That's why it is called matching resistance. So try to consider here circuit operation. All of you write circuit operation. The resistance potential divider are simple in construction, low weight, less weight. Only resistance R1, R2, then delay cable R3, matching resistance. Because of the weight of this equipment is very less, and lesser space requirement and is portable to any location. It's clear. The resistance potential divider are simple in construction, less weight, lesser space requirement, and is portable to any location. So that is the important point. Next one, the length of the divider depends on the highest voltage to be measured. The length of the divider, potential divider, is dependent on highest voltage to be measured. If you want to increase the range of the potential divider, I mean, for example, to measure the 33 kV, that is one particular length. And if you increase the voltage level 132 kV to 220 kV, like that, the range of the instrument, the length of the divider, potential divider, is depending upon voltage levels. For high voltages, compulsory the length of the potential divider is very high. Okay. The surface flashover gradient of divider resistance and stray capacitance related to time constants. RC is less than wave front time. Here, main concept is RC is less than wave front time. RC is less than wave front time. So then only the stray capacitance effect can be minimized. So then only the wave shape is in a proper way. So RC is less than wave front time. So try to consider the time constant of the circuit is less than wave front time. Here up to here, it's called wave front time. Na? So 50% means here 2.6 approximately. Here there is a 50%. This year to year time is called wave tail time here. So 0 to this time is called wave front time. That means, so by maintaining the RC is less than the wave front time of the circuit. Okay, the time constant of the circuit RC is less than the wave front time, then only the stray capacitance effect will be minimized. Otherwise, there is a disturbance in the wave front time and wave shape. There is a disturbance in this. Here we are getting proper way. No? Okay, in the smooth, there is no oscillation, so there is no disturbance in the wave shape. Okay, in order to get the wave shape like this, so we have to maintain the time constant of the circuit RC is less than the wavefront term. So then only the stay capacitance effect is minimized. Okay, understood. That is the main concept. And next, the potential divider must be matched. The potential divider must be matched to the equivalent resistance of the impulse generator to obtain a desired wave shape. Understood? The resistance potential divider must be matched to the equivalent resistance of the impulse generator circuit to obtain desired waveform. This is called matching resistance. By using this arrangement, okay, this impedance, the resistance R2 is equal to the impedance offered by the CRO. Okay, to adjust these impedances, so we are using matching resistance. Okay, and next, the value of matching resistance R3 is chosen such that R2 plus R3 is equal to Z. R2 plus R3 is equal to Z. Okay. Then the Z is represented the surge impedance of the shielding cable. This is called shielding cable. This is impedance, surge impedance of the shielding cable. Okay. The matching resistance R3 is chosen such that R2 plus R3 is equal to Z. R2 plus R3 is equal to Z means R2 plus R3 is equal to Z means, so the impedance offered by the CRO and is equal to the R2 plus R3. Then wave shaping, so we have to get the wave shape proper way. And the voltage seen by the CRO expressed as V2 is equal to R2 divided by R1 plus R2 into V1. Okay. The voltage seen by the CRO, the voltage across the CRO V2 is equal to R2 by R1 plus R2 into V1. Here R1 is very high resistance, na? R2 is very less resistance. R1 is very high. I'm already explained. This R1 is very high resistance, R2 is very less resistance. Then the voltage seen by the CRO is expressed by V2 is equal to R2 divided by R1 plus R2 into V1 means R1 is very high and R2 is very less, and this total voltage is very less. So that the less voltage can be measured easily by using CRO. Okay, that is the main concept. And low voltage elements of potential divider must be enclosed in a metal screen box to prevent electrostatic field and minimize inductance. Low voltage elements potential divider must be enclosed in a metal screen box to prevent electrostatic field and minimize inductance. Electrostatic field, external effects. So the low voltage elements are affected by easily external magnetic fields. Okay, that's why it must be placed in a screen box, metal screen box. So then only the errors presenting in a CRO to measurement and a measurement equipment, the errors are presenting error measurement equipment is very less. So try to consider here matching resistance may be located as shown in different ways. So here matching resistance here, no? Matching resistance here, the matching resistance and located in different ways. So here matching resistance at CRO side. This CRO, the R4 is called matching resistance. So understood. Matching resistance located at here. So what is the purpose of matching resistance? To suppress the transients. Matching resistance is used to suppress the transients and also observe the reflections and refractions of voltage waves. Reflections and refractions of voltage waves observed by my matching resistance. So then only the wave shape is, we will get wave shape is in a proper way. Okay. So matching resistance is placed at CRO side. So that's why the voltage across the CRO, so VT is equal to R2 divided by 2R1 plus R2 to V1. Understood? And also the matching resistance at both ends is only one end. The matching resistance is only one end. All of you draw the circuit. No? Okay. And the matching resistance at both ends. So here and here. So at that case, so you will get VT is equal to R2 divided by 2 times of R1 plus R2 into V1. It's completed. So R1 is very high, R2 is very less. This is called delay cable, or it is used to suppress the and by using this arrangement suppress the transients, and that is called reflections and refractions of voltage waves. Understood? So the matching resistance is placed on both not only one side and both sides also. Okay, so R3, R4 both ends. Okay, here one end, depending upon our requirement. Okay, this is called matching resistance placed across this here. So next, capacitance potential divider. Capacitance potential divider. I have completed this, and then next capacitance potential divider. So here this is input side, same as a resistance potential divider. This is called capacitor C1 and this capacitor C2. So here this capacitor C1, not a small value, is a series connected capacitors. That means number of capacitors are connecting in series, and then that can be considered as a equivalent capacitance. Understood? The number of capacitors are connected in series, and then we are converting into equivalent capacitance, that is called C1. And if you are connecting the number of capacitors in series, means the voltage handling by the capacitors are increasing. Here voltage across the C1 is very high. So in previous, here resistance we are used. Am I right or not? Resistance. Because of that, high voltage appear across the resistance R1 only. So then the R2, so we have to measure the resistance across this R2 resistance, low voltage easily by using CRO. Understood? So similar way here also, capacitor C1 is a not only one capacitor, is a number of capacitors are connected in series, and then the equivalent capacitance is called as C1. Okay, that means the maximum voltage takes place across the C1 only, and this V2 C2 is called very less capacitance. So that's why it is offers only it can store only some less voltages. Okay, this voltage can be easily measured by using CR. And the same as previous case, so we are using matching resistance through the delay cable. CD is called capacitance of the delay cable, and Z is called surge impedance of the delay cable, and CR. It's clear. So here, so one of the main concept CRO and capacitors across the C2 is this CRO, internal impedance of the CRO is very high in the range of mega ohms. Internal impedance of the CRO is very high, mega ohms. Okay, understood. So that means it acting as open circuit. Try to consider here. Internal impedance of the CRO is very high. It acting as just like the voltmeter. Okay, that's why you are connecting in a laboratory in parallel to the resistor only, in parallel to the capacitor only, not in series. Na? CRO is connected in parallel to the equipment, to parallel to the element, not in series. You are observing not in one of the experiment. Okay, so what is called RLC, under ampere system, delay time rastan, finding that RLC circuit. Okay, so you are connecting CRO in parallel to the element, in parallel to the capacitor, in parallel to the resistor. So not in series, na? Okay, if you are connecting in series, means there is no current passing through the CRO, that is acting as open circuit. There is no use of that. That's why the capacitor, CRO is connected in parallel to the element. Which where we have to measure the voltage, just like is a voltmeter, voltage, voltmeter. Okay, that's why it's connecting in parallel to the element. So that's why it is internal impedance of the CRO is high. That means it's acting as open circuit. Okay, so I think according to the power system concept, the long transmission lines are long transmission line is open circuited and short circuited, and short circuited with some impedance. So these are the different type of conditions. By placing, you have to observe the reflections of voltage waves, refraction of voltage wave, reflections of current wave, reflections of current voltage, reflection and refractions of voltage and current waves. You already studied, I think, in the long transmission lines, and by placing a open circuit at the end of the transmission line, and short circuiting at the end of the transmission line. Also, by placing one impedance with the okay. So that means under opening circuit condition, the voltage across the CRO is double the input side of across the C2. And here C2 across the C2, for example, voltage V. Okay, that means the output of the here at this side, the voltage will become double because of reflections of voltage waves and the refractions of voltage wave. Okay, understood. Try to consider here. So the CRO internal impedance is very high. Because of that, it is acting as open circuit. So because of that, transients and also reflections of voltage wave and the reflections of voltage wave, the voltage appear across the CRO is double the voltage compared to the C2. So that's why what we have to do. So we have to maintain the voltage across the input side of the delay cable matching resistance half of the voltage. Then the CRO can measure the double the voltage, means that voltage across the capacitor C2 and CRO will become same. Okay. So we have to maintain the input side of the CRO when matching resistance before of that. So we have to maintain the voltage half of the voltage. Then so we will get under open circuit condition 2 voltage. That means the voltage across the capacitor C2 and voltage across the CRO will become same. Okay, try to consider that's so. So try to all of you write this. The capacitance potential dividers are made of several capacitor units bolted together to form high voltage capacitor C1. I'm already explained. Capacitor C1 is very high capacitance value, and also it can withstand the very high voltages. Very high voltage. It can offer very high voltages. Capacitor C2 is made of mica and a tin foil plate electrode such that it act as an non-inductive link to the delay cable. It's clear. Understood? So one of the important concept here C2 must be non-inductive. Then only there is a errors because of inductance can be minimized. C2 must be C2 capacitance C2 is must be less inductive. Ideally, it's possible, but practically it's not possible. Practically 100% capacitance is not possible, but we are trying to reduce the inductance effect in the circuit. So because of inductance effect, there is a transient, there is oscillations observed. Okay. Because of that transient, because of inductance effect, uh, there is an oscillations in observed in wave shape. That's why to avoid that wave oscillations, the capacitor C2 must be non-inductive. Capacitor C2 is made of mica and tin foil plate electrode such that it acts as a non-inductive link to the delay cable. Okay, by making arrangement like this, the transients, the oscillations because of inductive effect can be minimized. So then there is no errors across the CR. Understood? For measurement of voltage less than 1 megavolts, the unit is portable, but for higher voltages, the unit is laboratory setup. Okay. For less voltages, unit is portable, but for high voltages, we have to keep at one place only, one particular laboratory setup. Okay. The voltage elements of the circuit are enclosed in the metal screen box with proper grounding to be minimize the electromagnetic interference. Understood? To minimize the external magnetic fields, to minimize the external stray magnetic fields. So the voltage elements of the circuit are enclosed in a metal screening box. Understood? Just like a moving iron instrument. The moving iron instrument is affected by the external stray magnetic field. So that's why it is placed in one screening box, but not in PMMC. The PMMC is a high magnetic, uh, permanent magnetic we are using. That's why this is not affected by the external magnetic field. But MI instrument is very easily affected by the external magnetic field. So same as like that, here also the low voltage elements of the circuits are enclosed in a metal screen box with proper grounding to be minimize the electromagnetic interference. Understood? So input of the delay cable. So the input voltage to the delay cable will be half of the voltage across the capacitor C2. I'm already explained. The input voltage to the delay cable will be half of the voltage across the capacitor. The input voltage across the delay cable will be half of the voltage across the capacitor C2, as resistance R and Z forms a potential divider and matching resistance R is equal to Z. Understood? So Y means the input voltage of the delay cable will be half of the voltage across the capacitor. Y means here we are to maintain the half of the voltage. Y means they under open circuit conditions, CRO it acting as a uh, uh, open circuit because of high internal impedance. So in that condition, the high voltage across the at the end of the cable, if you are maintain the open circuit, that voltage across the cable is here CRO is double voltage, 2V times voltage we are observe. We have to observe here 2V voltage. So to get to the actual voltage V, what you have to do, we have to half of the, we have to maintain the input of the delay cable half. Then we will get V times of voltage. Only V voltage across the capacitor, whatever the voltage appear across capacitor. So that voltage can be easily measured by using CRO, only V voltage. Otherwise, 2V voltage appear. If you are maintaining here 2 actual voltage V, so 2V voltage appear. So that's why we have to maintain input of the delay cable V by 2, then we will actual voltage V measure by using CRO. That is the concept. Understood? This is very important. Maybe in 2 marks questions, they may ask like this. Okay, then sixth one, the voltage wave, when it is reaches the CRO end, it gets double after the refraction, and as the voltage seen by the CRO is equal to the across the C2. Understood? I'm already explained this concept previous. Okay, the voltage wave when it reaches to the CRO end, it gets double after the refraction, and hence voltage seen by the CRO is equal to the voltage across the C2. This is the main important concept under capacitance potential divider compared to all. Okay. The reflected voltage wave back in delay cable is completely absorbed by the resistance R as capacitor C2 acts as a short circuit to the high frequency wave. Understood? XA capacitor. So for inductor XL is equal to omega L, XA is equal to 1 by omega C. Frequency and capacitance is inversely proportional. For high frequencies, it acting as a short circuit. Okay, you know well that concept. The damping resistance in series with the divider capacitance will improve the frequency range of measurement. The damping resistance in series with the divider capacitance will improve the frequency range of measurements, and that is called the matching resistance. The voltage transformation for ratio for high frequency is C1 by C1 plus C2, and the voltage transformation for low frequencies C1 by C1 plus C2 plus CD. Capacitance of the delay cable also we have to include for low frequency. Voltage transformation ratio for low frequency is nothing but C1 by C1 plus C2 plus CD. But for voltage transformation for high frequency, C1 by C1 plus C2. Only this. And summary. So this is the concept today. So we are completed. Voltage dividers require careful design while measuring very high impulse voltage with regards to the isolation of high voltage and low voltage circuit, electromagnetic interference, and portability. It's clear. Resistance potential divider are low cost, smaller size, and portable for most purpose. You know well. The matching resistance can be inserted on either side of the delay cable. I'm already explained. Okay. And the capacitance potential dividers are more complex and bulky, especially for voltage above 1 megavolts. The series damping resistance provide wider frequency range of measurement. Okay, so this is about measurement of impulse voltage by using resistance potential divider and capacitance potential divider.